Let's have a look at an application of what we looked at yesterday, an application in coordinate geometry, and that's if we want to find the angle between two lines on the number plane. So there's our first line, and I'm going to use the angles. So remember the way of finding the slope, which I said most people forget. The slope of a line is also equal to the tan of the angle it makes with the positive x-axis. So the slope of line L1 would be the tan of theta 1. And our second line, it also makes an angle, we'll call it theta 2. It'll have a slope tan of theta 2. And we want to find the angle between these two. So I can do a little bit of coordinate geometry. There's alpha, that's the angle I'm trying to find. And exterior angle of a triangle tells me that theta 1 would be alpha plus theta 2. So if I rearrange that, I want to find what theta 1 minus theta 2 is. So if I take the tan of both sides, it'll be the tan of theta 1 minus theta 2. But we now have a formula that allows us to expand that out. This one will be tan minus tan on 1 plus tan. But I can now substitute back in the slopes, because we said slope 1 was tan theta 1 and slope 2 was tan theta 2. So I get slope 1 minus slope 2 over 1 plus slope 1, slope 2. We usually say the acute angle, because obviously if two lines meet, one angle is going to be acute, one angle is going to be obtuse, unless of course they're perpendicular. So we usually say acute angle, and to ensure it's the acute angle, we go absolute value to make sure the tan is positive. And that'll get the acute angle between the two lines. So basically, it is just our tan formula that we saw yesterday with the subtraction. So let's find the one from 2000. We've got to find the slope of both of these, so I can use the formula. And the slope of the first one, of course, is 2. Slope of the second one is a third. It's simply a matter of substitution. Absolute value, 2 minus third. The nice thing about this, of course, is the denominator will always be the same. So I can tidy that quite easily. 6 minus 1 on 3 plus 2. It is just 1. One of our exact values, the tan of what gives us 1?
Pi on 4.
Pi on 4 if we're talking about radians, 45 degrees if we're talking about degrees. Okay, from 2005, this one was a little bit different. This time they actually told us the angle was 45, and we had to find the slope of the other line. We know the slope of the first one is 3, of course. So tan 45 will be 3 minus m on 1 plus 3m. And basically we now just have an absolute value equation to solve. Tan 45 is 1, as we just saw. So absolute value, either we'll make the positive of the left-hand side or the negative of the left-hand side, and solving those absolute value equations. Slope of a half, and logically the other possibility is going to be minus 2. Not a coincidence in this case, because we said the angle between them is 45 degrees. And so it turns out we get two lines that are perpendicular to each other. Because if you were to draw up the possibilities, you'd have 45 in one direction, 45 in the other direction, add them together, you get an angle of 90 degrees between the two possibilities. So we've ended up with two lines that are perpendicular, half and minus 2. Okay. That's all I really need to say. So, as I said, it's just a straight application of the formula from yesterday.